All right, welcome back, everybody. So, in this session, let's take a look at logical operations on bits. The last session, we discussed about arithmetic operation where we did addition and subtraction. But in this session, let's take a look at logical operation on bits, not arithmetic or logical operation. So, what are logical operations? All right. What are logical operations? Logical operations are on bits involve logical operators to manipulate binary data. So we have the zeros and ones, which is our bits. Now, but we also have, instead of having arithmetic, like the plus or the minus operators, we have other operators that we call logical operators. Something like the AND operator, the OR operator, the NOT operator, the exclusive OR operator. We'll be taking a look at them one by one. But these operations are fundamental to low-level programming, embedded systems, and computer hardware. Now, the reason why we actually said that you should take this course, this foundational course, is that you don't know where you're going to actually specialize. Okay, that is why you need to have this foundational course. You can get into system programming, you can get into embedded systems, you can even get into computer hardware. So you never know where you're going to land. So now, each bit is either 0 or 1, which we already know. And when it is 0, it is false. And when it is 1, it is true. Okay, so it is 0 or 1, these are the bits. But when we talk about the Boolean value of it, 0 is false, 1 is true. So these are the Boolean values. These are the logical variables, okay? These operations work bit by bit on binary numbers. So when we talk of the logical operators, all right, manipulating bits, we are going to see how they actually manipulate on bit by bit level. Okay, so now there might be a confusion between logical operators and bitwise operators. In short, when I started programming, I always run away from bitwise operations. Now, but because I finally took a course like this, I got to understand what they actually mean. All right, it's not actually difficult. So we have logical operators and we have bitwise operators in programming languages like JavaScript, Python, C Sharp. We have what we call logical operators and bitwise operators. So that we are going to understand these things even before we start talking about programming languages. So a logical variable operates on logical operations operate on a logical variable. They operate on logical variables. So these logical variables are either true or false. Do you understand? These values are either true or false. If it is 0, it is true, it is false. If it is 1, it is true. All right. So a logical variable can have one of two values. It's either a 0 or 1. Now, but when we talk about logical operators and bitwise operators, when we talk of logical operators, we are looking at 0 to be false and we are looking at 1 to be true. When we talk of bitwise operators, we are looking at 0 to be 0 and 1 to be 1. You understand the binary values. So, of course, we are going to be explaining more about the logical operators and the bitwise operators. But I want you to understand, okay, there are two perspectives you can actually look at. You can actually have about two perceptions. You can actually have about zeros and ones. Zeros and ones could either be bitwise, like the normal binary zeros and ones, or it can be logical variables like false or true. Do you understand? So when you're looking at it from the angle of logical variables, 0 is false, 1 is true. When you're looking at it from the bitwise operation, 0 is 0, 1 is 1, binary values, okay? So most programming languages actually have this, okay? So we are also going to be understanding better. But before I continue, I want you to understand, in case these things are not sinking in, all right? Don't beat yourself. Go and watch this video over and over again. All right, you see this class, take it whenever you don't understand something, take your time, watch it as if you're watching a movie. All right, then come back again, try to assimilate it. If it doesn't enter, watch it as if you're watching a movie again. Then by the third time it will enter. Now the thing is this, the when as once you, even if you're watching a movie, you don't actually grab every details of the movie. Most times when I watch a movie, it is the second time or even the third time that I get to understand that movie better. That is how the brain operates. It's not just because of it's a computer science course. No, this is how your brain works. When your brain gets something that is new, there is a way they process it. So repetition is the mother of mastery. So don't beat yourself too much. If you have any questions, while as you're taking this class, be taking notes. All right, be making notes of questions you would want to ask. All right. So the name logical is actually historical one. It comes from the fact that two values, zeros or one, can represent two logical values, zero and true or false. So now when we look at it from the angle of being true or false, zero can represent false, while one can represent true, then we are talking of logical variables. All right. But when we are talking of zero, the binary values like zero or one, zero and one, we are looking at the bitwise variables. Okay. So there are several basic logic functions, and most ALUs perform all of them. We'll be talking about the organization of a computer, and we'll be talking about ALU, which is the arithmetic and logic unit. Okay, so it is we mentioned it in previous sections. It is arithmetic and logic unit that performs these mathematical operations and these logical operations. So arithmetic and logic unit. So this is the unit where arithmetic and logical operations are being performed. So we have logical functions like the and, the or, the exclusive or, the not. We'll talk about them later on. But in this particular session, we'll be talking about the and logical operator and the and bitwise operator. Okay, so these operations are often called bitwise operations. Why? Because when you apply these operations on the bits, all right, you are actually it is actually a bitwise operation. But when you apply these operations on logical variables can either be false or true. All right. If you apply it on logical variables, they are called logical operators. But when you apply them on bits, the zeros and ones level, they are actually called bitwise operations. So these are operations that operate on bits. So you're going to see the difference. We'll also write some JavaScript code to explain more to this. All right, so let's take a look at some differences. Let's compare this logical operation and the bitwise operation. I want you to get this thing very clearly. All right, so now these are the features. All right, so for the operators, we have the and operator, all right, the or operator or the not operator. All right, and this is their bitwise counterpart. Okay, don't worry, we are going to do so many examples for you to understand. Just follow along. All right. So the operands that logical operations operate on are called Boolean values, either true or false. But for the bitwise operators, they operate on binary bits. So look at the differences. Logical operators operate on Boolean values, true or false. All right, that's logical variables. While bitwise operators operate on binary bits, zeros and ones of integers. So if I want to say I want to perform a bitwise operation on two integers, the system, the programming language, the computer will perform these operations on the bits of those integers. All right, but if I want to perform logical operation on any integer, depending on the programming language, those integers can either be seen as true or false. So the operands of logical operators are Boolean values or logical variables, true or false, while the operands of bitwise operators are binary bits. So logical operators return Boolean results, true or false, while bitwise operators return a bit level result, another number. Okay, they will return another number. So use cases for programming languages, we use logical operators for conditional logic, but for bitwise operators, we use it in low-level data manipulation. Okay, it's okay, just follow along. All right, just try as much as possible to grab. Okay, so these are some of the differences in the comparison we have here. Now let's go. Logical operations, they are used in control flows such as if, while statements in high-level programming languages. So you only care whether something is true or false. That's what logical operators actually care for. Now, they are common in high-level programming language. That's where you see it. JavaScript, CS, C Sharp, C++, C, Java. That's where you see this that's where you see these conditional logical operators. So something like this, let S equals to true, Y equals to false. If we console this thing now, this is the operator. So let me take you to the browser. Let me take you to code. Let's see the difference. Okay. Don't just be following me, all right? Don't bother too much. Just try to understand that we are talking about logical operators and bitwise operators. All right. Now, I have something like this. Look at it. If I say console.log, I say 7 and 6. All right. This is JavaScript programming language. All right. This is the logical and operator in JavaScript. So JavaScript is going to, the two operands here are 7 and 6. So since we are working with logical operator here, JavaScript will see this thing as either true or false. All right. So if I run this now, we are going to get true because both of them are seen as true. Do you understand? Okay, so there's something we call short circuiting operation, but don't worry. That's not why we are here. Okay, we just got a different result to what we are expecting. But there's a reason why it's 6. Okay, but if I say true, don't worry, you will learn all these things when you start learning computer, when you start learning any of the programming languages. If I say true, all right, it is going to give me true. All right. Okay. So, but if I want to do the bitwise operation, all right, if I say 7 and 2, there will be the bitwise operation would go to the bits. All right. So we are going to go to examples to show you. So you can see we are having a different okay. So this will be applied on the bit level. Okay. So now let's go back to the slide. I'm going to show you an example. So this is the logical operation here, the logical AND operator. All right. Yeah, this is the logical OR operator. So the bitwise operations operate at the binary levels. After each bit in the numbers, it affects each bit in the numbers. All right. So when you're working with bitwise operators on numbers, they are affecting each bit of the numbers. So they are common in low-level programming language such as hardware control, cryptography, compression, and embedded system. This is where you mostly use bitwise operations. All right. But for logical operations, you mostly use it in high-level language like JavaScript, C Sharp, or Java. Okay. So the common confusion and this symbol, one of it is just the bitwise and, while double of it is the logical and. They will give you different results. Okay. So they look similar, but they are very different. They are very different. So this is the bitwise and operator. This is the logical and operator. Okay. So when we take a look at the summary here, the logical operators work on Boolean values, while bitwise operators work on bits of the integers. All right, they evaluate overall condition, but this one is on each bit. So without wasting time, let's now go into the main thing why we are here. We have understood the difference between logical operators and bitwise operators. So what we are going to be discussing right now is the bitwise AND. All right, we will not be discussing the logical AND because we are not dealing with here. We are actually dealing with bits, so we are not dealing with logical operators. Okay, right now we are not talking about logical operators, but when we'll talk about logical operators when we start talking about programming languages. Okay, so bitwise AND operation takes two binary numbers and compares each pair of corresponding bits. So bitwise operators work on the bit. So for each bit position, the result is 1 if both bits are 1, and 0 if both bits are otherwise. So let me take you to the board. So if I have two binary numbers, okay, even if you have a decimal number to work with, you have to convert it to binary number first. So if I have this binary number 1 0 1 0, all right, and I'm performing the AND operator, which is the bitwise operation here, the AND bitwise operation. So if I have another one 0 0 1 1, okay, so just like our slide said, okay, we compare each bit in the different positions. All right. So we look at all they have to have the same number of the same size. So we compare each bit on each position. Okay. So the result will be 1 if both bits are 1, but the result will be 0 if any of the bits is 0. The result will be 1 when we are doing bitwise AND. The result will be 1 if both bits are 1, and the result will be 0 if any of the bits is 0. So let's go back to our board. So now we are doing bitwise AND here. All right. So this is a logical operation. Remember, we are not talking about the logical operator here. We are talking about the bitwise AND operator. When we get to programming language like C, C++, we're not talking about the logical operations. But right now we are talking about the bitwise operator. So bitwise AND operator says that the result of we will compare them on different positions. We'll compare the bits on different positions. All right, just like we do the addition and the subtraction, we are doing the same thing here. So we are comparing. 0 and 1 will give us what? 0. Why? Because remember, it says that the result will be 1 if both of them are 1, but otherwise it will be 0. See, if any of them is 0, the result will be 0. But if both of them are 1, the result will be 1. So 1 and 1 will give us 1 because both of them are 1. 0 and 0 will give us 0 because not both of them are 0. 1 and 0 will give us 0, 0 because both of them are not 1. Do you understand? Okay, so you can see that we have a different value here. Okay, so when we AND them, this AND operation is working on the bits. That's why they are called bitwise operators. They are working on the bits. Okay, so it is a binary operation, meaning it operates on two operands. All right, it is binary because it means that it has two operands. We have binary operators, we have unary operators. It is a binary operation because it is working with two operands. We also have unary operators. So when we talk about the NOT operator, that one will be a unary operator. So when we have an operation or operator that requires two operands to function, then it is a binary operator. Okay, so look at the truth table. Truth table is what we use to know what we are having. So we have variable A, we have operand A and operand B. When we AND the two of them, when A is 0 and B is 0, remember the AND operator says that if any of them is 0, then the answer will be 0. So one of them is 0 here, so the answer is 0. In the second level, one of them is 0, the answer will be 0. The third level, one of them is 0, so the answer will be 0. The next one, both of them are 1, so the answer will be 1. Do you understand? So this is a bitwise operation that we have done on this binary digits. Okay, so you work on each of them on a positional level. This position goes here like this, like this. Okay, so now let's take an example. Now look at A is equal to 13, and the binary representation of A is 1101. This is the binary representation of 13, and B is 11, and this is the binary representation of 11. So when we do the AND, remember, when we do the AND, we'll do it on each position. So let's take the first position, which is the leftmost position. Both of them we have 1 1. So both of them will be 1. All right, we'll have 1. 0 and 1, 0, because one of them is 0. 1 and 0, 0, because one of them is 0. Then 1 and 1 will give us 1. So we are having 1 0 0 1. So this is the result. 1. Okay, so no. Okay, so this is the result. All right. 1 0 0 1, because 1 and 1 will give us 1 because both of them are 1. Remember the AND operator. 0 and 1 will give us 0 because one of them is 0. 1 and 0 will give us 0 because one of them is 0, and 1 and 1 will give us 1. So this is the decimal representation of this. So now if we go back to our code now, we are having 13 and 11. All right, let's go and write it in code. Let's go and do this bitwise operation in JavaScript. 13 and 11. Let's go to JavaScript. So I'm going to say 13 and 11. It should give us 9. All right, you can see we got it here, 9. So this is the higher level implementation of the AND operator. This is the bitwise operator here. It is not the logical operator. The logical operator in JavaScript is double of this sign. All right, so this is the bitwise operator here. So let me take you back to the slide. All right, I want us to do this example again. 13 is 1 1 1 0 1. 11 is 1 0 1 1. So I hope I will remember it. 1 1 0 1 1 0 1 1. 1 1 0 1 1 0 1 1. So let me go to board. So I will have 1 1 0 1, and then I have what was it again? 1 1 0 1 and 1 0 1 1. Okay. I have 1 0 1 1. So this is 13 and this is 11. All right. So when we do the bitwise AND operator, all right, we do each level. 1 and 1 will give us 1 because both of them are 1. 0 and 1 will give us 0 because one of them is 0. 1 and 0 will give us 0 because one of them is 0. And 1 and 1 will give us 1 because both of them are 1. So this will give us 9. So even if you want to perform something like this, you want to perform the bitwise AND operation, and you don't want to go into the binary bit level, you can just go to any of your programming language and do it here. So we said 13 and 11 will give us 9. That's exactly what we got. Okay. So I hope you grab it, but in case you don't grab it, please reach out. Make your notes of the things that are confusing you. Reach out to us for more explanation or watch the video again. All right, watch the video again. So what are the real life applications of bitwise AND? So there's something we call bit masking. All right, in the next class, we'll be talking about bit masking. You can use AND to check, clear, or extract specific bits in a number. So I'm not going to go into details of bit masking because I have not explained it. So we'll dedicate a separate session to understand bit masking. All right. So we use it in bit masking. We also use it in checking even or odd numbers. So now, remember, a number. Now here, this is a code that we have. I'm going to write this code in JavaScript and then I will explain it to you. Okay, let's go to code. I will say, this is what I want to do. I will write if, let's assume we are comparing. Okay, let's assume we have a number. Let's say we are comparing 7. Oops. We'll call it num is equal to 7. So we are comparing, we want to know if this number is even or odd. So we'll say, let me do 5 so that I will have Okay, let me do 7. Okay. I will now say num bitwise and, all right, 1. Okay, I'm going to explain what this code actually does. Okay, I will say console.log. I will say console.log, or I think odd or even. And okay, yeah, it will be odd. Otherwise, else, I would console. That means the number is even. Okay, so I'm going to explain to you how we're actually going to use this AND operator to determine whether this is even or odd. So when I run this code, of course, 7 is an odd number, so it will give us odd, because 7 is an odd number. It's taking long. It's taking enough. It's taking too much time to run. Let me just refresh the page. Okay, but now let me go and explain to you what we are doing here. Okay, so let me run it again. 7 is actually odd, so we expect it to be an odd number. But if I change this 7 now to be 6, it will give us an even number. So if I want to, let's say I write a program in JavaScript now, and I want to check, quickly want to check if a number is odd or even. I will just use this particular algorithm to find it out. Okay, so now let me go and show you what this thing actually means. We are saying a number and 1. So let's go and look at the binary representations of this. Okay, so now um, the binary representation, let's check if 3. Let's check if 3 is an odd number or an even number. The binary representation of 3 is 0, 0, 0, 1, 1. I believe so. All right. So in that our code, we are doing and we are ending it. We are ending it with 1. Binary representation of 1 is 0, 0, 0, 1. All right. So that means whatever, if we do this thing, all right, if we end it, we should get, the result should be an even number. Okay. Now, remember, okay, so 1 and 1 will give us what? 1, because both of them are 1. 1 and 0 will give us 0. 0 and 0 will give us 0. And 0 and 0 will give us 0. So you can see here now, we are having 1. Do you understand? Okay. The result is we are having 1. When we add the two of them, this is an odd number. But let's try and work with 2. Okay, 2 is an even number. So the final representation of 2 is 0, 0, 1, 0. So when you add it with 1, which is 0, 0, 0, 1, all right, you will see that 0 and 1 will give us 0. 1 and 0 will give us 0, 0, 0. Do you understand now? This is 0 representation, because now, how do you get to understand if a number is even or not? If you divide it by 2, the answer should be 0. So you can see that now when we do the AND, we got 1. So any odd number, if you AND it, you're going to get, you should get 1 as the you should get, if you any odd number, if you want to know that a number is odd, just do the and it with 1, all right, which is what we just did here, and we got 1. For even numbers, and it with 1 and you get 0. So let's go and confirm from our programming language. So instead of doing this, I'm just going to say, all right, I'm just going to say console.log. Let me choose 7 is an even number. Then I will AND it with 1. So this should give me 1. Remember, if you AND an odd number with 1, it should give you 1. All right, we should get 1. But if I say an even number, which is 6, if I AND an even number with 1, I should get 0. Do you understand? You can see. So this is the logic here. So with this now, we can know what is an even number and what is an odd number. So basically, when you're using the AND operation, so basically what I want you to understand here is the AND operator. All right. If you're writing a programming language, this is the symbol for it. But if you want to go bitwise, you actually have to go every position and you get it right. Okay. So now, and the least significant bit of odd numbers is always 1. The least significant bit of odd numbers is always 1. Now, if we follow this thing now, let's go back to our what's it called again? Let's go back to our board. They said the least significant number is of odd number is always 1. So look at it. This is an odd number, and this is the least significant bit. This one is the LSB, the least significant bit. While this one, the rightmost one, is the most significant bit. We have talked about this one before. So for even numbers, the least significant bits are always 0 for even numbers. But for odd numbers, the least significant bit is always 1. So you can check it out. All right, you can check it out. And whenever you AND this with 1, you will always get 1. If you AND an even number with 1, you would always get 0. All right. So I hope you guys are capturing this. So basically, this is what we have been talking before. All right. So when you get to computer programming languages, you get to understand what we mean by short circuiting. All right. When you get there, you get to understand what we mean by short circuiting, but we won't be talking about it now. All right. So in summary, when to use by bitwise and when dealing with bit level operations, that's when you use bitwise and. In short, most of my programming, most of the code I write, I don't use bitwise and because there is no need. I'm not working with bit level operations. So, but in case I found myself working in a project that needs me to work on the bit level operation, then I can now do the bitwise operations. Okay. So in hardware, firmware, and embedded system, this is where you use the bitwise and. For optimization in low-level code, then in security permissions or networking, in graphics and in game engine programming. So basically, when you get to maybe doing graphics or game engine, you're going to be using these bitwise operators. So in this session, we just talked about the AND bitwise operator. All right. So remember the truth table. Both if you're comparing the positions of these bits, if you have two variables, you have two operands, you have the first sequence of bit and the second sequence of bit. If you want to AND the two of them, you actually have to go it position by position. And you will AND, if you AND the two bits, it will give you 1 if both of them are 1, or it will give you 0 if any of them is 0. Thank you very much. Do your test. Most of these tests, most of the questions we give you in the test, we actually try to make you stretch your brain. So in case you find anyone difficult to answer, reach out to us. Yes, we want to stretch your brain so that we know that for you to get to understand this thing. So in case you don't really get it, please reach out to us. That's why we are available for your mentorship. Thank you very much, and I'll see you in the next class.